cruel Mother Nature is playing a joke on me. As you can hear, I sound a little stuffy. Unfortunately, the gods have placed a curse on me. I am inflicted with the flu, so I sound a little odd. Now, that aside, we are going to crack SQL 50. It is a compilation of 50 SQL questions on LeetCode intended to help you prepare for a SQL interview or just a really easy and efficient method to practice your SQL skills. It's basic to intermediate questions with only one hard question, I'm sure. Let me confirm. Yeah, only one hard question. It's best for 1 month of prep time. I'll be honest, I've been doing it for 3 months because I have other stuff to do. And it's 50 questions. I mean, duh, SQL 50. The most important thing, however, is this cool icon. I mean, look at this. That's so cool. Wait. Alright, before I end up playing with that for a solid hour, let us begin. Where'd my solution go? Anyway, we notice we have a table called products. And don't we all get happy when there's only one table? We've given some information. Product ID is a primary key for this table. Low fats and recyclable are both enumerable categories. All that means is there is a tuple with select values in them, and low fats and recyclable can only be a value within that tuple. We have to write a solution to find the ID of all products that are both low fat and recyclable. And because the LeetCode overloads are so generous, we can return the result table in any order. This one is very simple. If we were to do a select of product ID from the table, that be in products, that would grab all the products, right? But we don't want that. We only want it where, which is essentially an if statement. So if low fats is equal to yes, which I got from the enumerable possibility here, y being yes, n being no, and again for recyclable. So where low fats is equal to yes, and I don't like that, and recyclable is also equal to yes. Alright, and that should solve it. Alright, there we go. Start the study plan, track your progress, and focus on daily questions to make consistent growth. No, I'm good. Thank you. Let's see, runtime. Also, watch this. You see this solution. It's the exact same thing. You see this solution. It's the exact same thing. The machine you are writing on could play a part in this. The manner in which you write your answer could play a role in this. So don't feel bad if you get varying runtimes for the same solution. It's not a big deal. Relax. Don't feel sad. Alright, next question. Find customer referee. Referral, referee. Referee, right. Find customer referee. So let's get rid of that solution. Confirm. We are given the table customer. In SQL, no, really dude, what else? In SQL, ID is the primary key column for this table. Each row of this table indicates the ID of a customer, the associated name, and the ID of the customer who referred them. Find the names of the customer that are not referred by the customer with ID 2. And again, because the LeetCode overalls are generous, we can return the table in any order. Alright, cool. So if we were to select name from the customer table, that will return all the names, right? But if we were to filter down that very large table and only consider where the referee ID is not equal to 2, let me show you here before I write the rest of my solution. Let's look at the table here, customer table. This table, okay. The customer with ID 1 has a name of Will. Who referred Will? No one, because it's null. The same with James. It's null. Who referred Alex? Well, whoever had a referral ID of 2. That being Jane. We don't like Jane. We're not going to consider anyone who has been referred by the unholy being who goes by the name Jane. We look at Bill again, it's also null, and null is not 2, therefore Bill's a cool guy. Well, what about Zach? Zach has been referred to by 1. Who's 1? Well, 1 is Will. We like Will, so Zach's cool. What about person 6? Name Mark, referee ID 2. Oh my god, get out of here. Again, Jane. We don't like Jane, and therefore we don't like Mark, because this lead code question is essentially, how can I put it in kind words? It's playground fighting. So referee ID is null. If we run that, dude, someone is having a war in my house. Referee ID, I can't spell apparently. Let's see. REFEREE underscore ID. And submit. Now, I've been going pretty slow. Oh my god. Later. No, I messed up there. Should have said don't remind me today. Anyway, alright, there we go. Cool. Very simple. Let's go to the next question. Big countries. Woohoo! Let's get rid of the solution. Alright. Name is a primary key for the table world. Each row of the world table gives information about the name of a country, the continent in which the country is found, its area, the population, and its GDP. Now, we also told something else. A country is big if and only if it has an area at least 3 million, a population of at least 25 million. That's honestly very simple because we are told write a solution to find the name, population, and area of all the big countries. And again, in any order, so you know, that's really nice. Here's the world table. As you can see, we have Afghanistan in Asia, an area of 652,230, its associated population, and its GDP. Is Afghanistan a big country? Yes. Population enough, and let's see, GDP. They don't care about GDP, okay. So if we were to select name, population, area from the table, that being world, but we only want to do it where area is greater or equal to, and let's see, can I just copy that? Sure. There we go. Or population is greater or equal to, let's see, copy that. I swear on God. There we go. And that's cool because essentially we had this very large world table with all of these 3, 4, 5 countries, but we only wanted to consider the countries that are considered large or big. So we had to filter down this large table into a smaller table. And we did that by only considering entries where the associated area was greater than that amount or the population was greater than this amount. Now we'll submit this. I'll drink some coffee and try to breathe with one suffocated nostril. Nice try, study plan. Now I got you. Yeah, don't remind me today. Why is there a checkbox? Because if I go to later, will you pop up again? Alright. That's cool. Simple stuff done. Let's go to the next question. And it's called Article Views 1. Doesn't matter, reset it. Alright. We have a table called Views with 4 attributes, 4 columns, whatever you want to call it. They both are valid. We are told there are no primary keys for this table, so possibility of duplicate rows is pretty decent. Each row of this table indicates that some viewer viewed an article written by some other author, could be themselves, on some date. Note that equal author ID and viewer ID indicates the same person. Alright, it was like me when I first started posting on YouTube. I would post a video and watch it myself. I know, cringe. Anyway, we have to write a solution to find all the authors that viewed at least one of their own articles. And this one's hard because we need to return the table sorted by ID in ascending order. So here's an example here. We see the output is 4 and 7. So let's look at a person with the author ID. So author ID of 4 who viewed their own work. So 4 and 4, so that's valid. And then we look at 7. 7 also appears. Okay, so that's the ones we need. So select author ID as ID, and I know that because look in the output, it says ID, from the views table because there's no other table, where the author ID is equal to the viewer ID order by author ID. Now this solution will not work. We need to wrap this in distinct because we need to account for the fact that there may be duplicates. All right, submit. Podcaster. All right, and let's go on to let me actually check something. Yeah. There's no originality in SQL. It's all the same. I say it like my one is any different. All right, let's get that. Invalid tweets. Which tweets are valid? The short answer, none of them. We have a table called tweets with only 2 attributes, tweet ID and content. Tweet ID is the primary key for the table. It contains all the tweets in a social media app. We have to write a solution to find the IDs of all invalid tweets. And it tells us a tweet is invalid if the characters used in the content is strictly greater than 15. And we can return the table in any order. So select. Let me see. I'm trying to... I'm getting off those... How can I put it lightly? There's phlegm in my throat, and it feels weird. Anyway. Select tweet ID, because that's what's important. From tweets, right? Where, and now if you're unfamiliar, SQL actually has functions available for you to use. One of those are called char length. You can pass in a attribute that is of type char, such as content here. You see it's a variable char, and it will spit out the length of that character string. If it's greater than 15, it's invalid. Therefore, we do that and we try submitting. And there we go. Essentially what we did was we had this large table, well, 2 tuples or 2 entries, or 2 rows, and we wanted to filter it. We wanted to reduce the tweets table to only consist of a tweet ID where the content was greater than 15. No. Yeah, where the contents were greater than 15. And that's why we did that part there. I almost confused myself. Submit. There we go. Next one. I need coffee. All right. Replace employee ID with the unique identifier. We have, oh my god, we have 2 tables. ID is the primary key for the table employees. Each row of that table contains the ID and name of an employee in some fictional company. And then we have employee UNI. ID and unique ID is the primary key. Okay, so it is a combination. It's an unholy fusion dance of 2 attributes. And each row of this table contains the ID and the corresponding unique ID of an employee in a company. We need to write a solution to show the unique ID of each user. If a user does not have a unique ID, just show null. And again, we can return any order. Here's the input tables examples, and here's an example output table. All right, cool. And they have an explanation here. And if you're ever in trouble, typically, well, not typically, every now and then, there are helpful hints on the bottom in this area. What else you can do is look at the discussions tab. You are going to find solutions because people refuse to follow rules. But just, this is going to sound weird. Just don't look at the solution. Just go read what people are saying. At times, like not now, but there are times when you will approach a problem that isn't explained very well. So don't feel bad if you need it to be further explained to you. But this one is quite simple. If we were to select employee UNI, so that's the actual table name, right? I can do dot access operator. I can do unique ID. So this essentially says grab the unique ID from this table. I also want to grab from the employees table the employee's name. From employee UNI. Now what I can do here is I can also pass in the employees table, right? And then I'll have access to two tables, and then I can grab both of those associated values. But I'm not going to do that. I'm going to do a right join. So only get stuff from the right table. Wait, the right table, yeah, should be. Right join employees on employee UNI.id is equal to employees.id, which is a nice way of saying essentially grab everything from these two tables, okay? But only do it where the IDs match. And there we go. And there's no need for us to do a little null, because by default it will show null because that's just how right join works. And if we submit this, and if I drink coffee and now I have a headache, cool. This video was going so well. 2,371 milliseconds, what? Also something else, if you write your solution in lowercase, for whatever reason, it tends to be a little faster. I don't know why. Anyway, next one. Product sales analysis. Confirm. We have two tables again. We have the sales table with a sales ID, a product ID, a year, quantity, and price. 5. That's an ungodly amount of attributes. So we're told that sale ID and year is a primary key. So it's a combination of two columns to make up the primary key for this table. This table is not in 1NF. Wait a minute. Where's my phone? Am I confusing myself? I'm not trying to open Tinder. I'm trying to open up Google Chrome so I can search for something. It's definitely NF, right? Normal form. Yeah, the word is normal form. 1 NF. First normal form, correct. 1 NF. Yeah. Anyway, we also told that product ID is a foreign key. All that means is it is the attribute that references another table. In this case, the product table. We also told that each row of this table shows a sale on the product ID in a certain year, and note that price is per unit. We next have the product table. Product ID is a primary key for this table, and each row indicates the product name of each product. We have to be very crafty and write a solution to report the product name, year, and price for each sale ID in the sales table. What if I just say no? What are you going to do to me? What if I do all other questions and I just leave this one out? And instead of being SQL 50, it's SQL 49. What would you do? Nay, what can you do? Exactly. If I were to select wait a minute, product name, that will be from the product table. Okay, so from product, let me go up here, and if I were to do year and price, also from the product table, I will join on sales. Wait, why am I? No, dude, there's no need for me to be all caps like I'm screaming at the monitor. Join sales on product dot product ID is equal to sales dot product ID. Hey, yo, dude, look at that. It's the same. Amazing. So we only got the name of a product, the year, and price, where that product exists in both tables. And we did this by joining the products and sales table where their IDs were equivalent. Cool. There we go. Oh, that's abominable. Must be nice. Let's just see what happens if I just resubmit it. Now it's never gonna complete. Oh my god. Yeah, it just sits there in runtime hell. Anyway, next question. Alright, customers who visited but did not make any transactions. Alright. That's valid though, right? Sometimes you don't want to buy anything, you just want to look at stuff. Alright, I will just reset that. We have two tables, visits, which has two attributes, visit ID and customer ID. Visit ID is a column with unique values for this table, and it contains information about customers who visited a mall. We then have the transactions table. Wait a minute. Phew, I thought I didn't have a microphone on. I was going to spaz. Alright, table called transactions. Transaction ID, visit ID, and amount are the three attributes, and we are told transaction ID is the column with unique values for this table. And the table contains information about the transactions made during the visit ID, and maybe it's not a great idea to talk so much when my throat is sore. Alright. Write a solution to find the ID of the users who visited without making any transactions and the number of times they made a visit with no transactions. We can return the table in any order. Here's an example. Here's the outputs table, right? This is what they expect from you. This thing here, this chunk. Wait, what? This chunk here. That's what they expect. Let's look at customer ID 54, which is this dude here. Has visited, no, yeah, all right. Here we go. 54 and that. If we look at the transactions table, we notice that the associated visit ID is 5, which means this one is 5, right? Okay. Customer with ID 54 visited the mall 3 times. During 2 visits, they did not make any transactions. And during 1 visit, they made 3 transactions. Am I on some goofy juice? Oh, okay. When the customer with the customer ID 54 with the associated ID of 5 visited, they made as we see, because this exists in the transactions table, it means they went to the mall and purchased 3 times for the value of 200, 300, and 310, okay? But then, when that same customer with an ID of 54 and a visit ID of 7 and a next time as 8 visited, they did not make any transactions. And we know this because what they are essentially telling us is if a person exists in the visits table, they have definitely gone to the mall. Alright, that clears up my confusion. So select, let me wait, it's customer ID and count, okay. So customer ID, and I use a SQL function count. And I'm going to count the customer ID actually as count number transactions from the visits table, okay? Now, if I just did this is not going to work for many reasons. One of the reasons being is it gives us one output. The way we solve that is by doing a group by. Now it will count for each customer ID instead of aggregating for one row only. But this will also not work because we need to do something else. We need to do where visit ID not in, and now create for a subquery. It will be visit ID from transactions. Let me just go through this. Okay, if I select a customer from visits where the visit ID does not exist even though they visited, and I group by customer ID, yeah, okay, that will work. Yeah. And there we go. 2000 milliseconds and it beats 95%. Hey, same thing, dude. There's no need for you to abbreviate that name. Wait, why was the name given an alias? Just because you're referring to it over here? Okay. That's fine. Let's go to the next question. What was I... Oh yeah, I was trying to tell myself how to do it. I was teaching myself at runtime what to do. And I taught myself successfully. Alright, let's look at the next one. I'll actually leave that comment up here. Table is called whether we have 3 attributes, 2 integers, and 1 date type. ID is a column with unique, okay, ID is a primary key. There are no different record rows with the same record data. This table contains information about the temperature on a certain day. Cool. Write a solution to find all the dates only where temperature of that day is higher than yesterday. Return the table in any order. And that's why I wrote this comment. Select ID from whether where temperature is greater than previous day temperature. Now, let's see. Okay. Input is the weather table. The output is 2 and 4. If I look at 2, the temperature is 25. The day before is this day and temperature is 10. Okay, valid. We can't say that about 3 because 3 is 20 and the day before is 25, so it's lower. We can say yes for 4 because 4 is 30 and 3 is 20, therefore valid. Okay, so select ID from weather. That will select all the IDs. If I were to do an as w1 and I'll create another weather table as w2. So now I have 2 weather tables because I want to do something. Where I'll take advantage of another function. So it's date minus date. Let me check that function. What? Date minus date. Date minus date. Date subtract. No. Date diff. Diff or is difference? Diff. Okay. Date difference. This can take 2, so it'll be D1, so date 1 and date 2, and it will essentially see the difference between those tables and spit out a value in the number of days, I believe. Now, because I have 2 weather tables as W1 and as W2, I can do this. W1 dot record date, if I could spell, and W2 dot record date. The difference between them must be equal to 1 because we want them 1 day apart. And once we have dates that are 1 day apart, I want to make sure that w1.temperature is greater than the previous day's temperature. Now, this is not a too bad question. Obviously, if you aren't aware that SQL has functions that you can take advantage of, this question may be a little difficult to comprehend. And clearly I lied because I have no idea what I'm doing here. Alright, so it should be W1. Alright. And one of these days, I'll tell you how I passed and simultaneously failed an Amazon interview. 16%. 16%. Date ad. Date ad. I don't even want to look at that. Alright, next one. Average time of process per machine. Oh my god, I remember this question. It says easy. It's not easy. Alright, are you ready? I am not ready. I need water or something. My throat is killing me. Alright. Average time of process per machine. We are given one table called activity, 4 attributes, 2 integers, 1 enumerable, and 1 float. Machine ID, process ID, activity type, and timestamp. We are told the table shows the user activities for a factory website. Machine ID, process ID, and activity type is the primary key for this table. Machine ID is the ID of a machine. Process ID is the ID of a process running on that machine. So like you can think Google Docs, Excel spreadsheets, Epic Games, VS Code, calculator, Microsoft Whiteboard. What is this? Armory crate. And activity type is an enumerable category, which nice way of saying there's a tuple and it can only be the values in that tuple. In this case, start and end. Why are my headphones hurting my head? Alright, that's better. No, it's not. Okay. And we are also told that timestamp is a float representing the current time in seconds. Start means the machine starts the process at the given timestamp, and end means the machine ends the process at the given timestamp. The start timestamp will always be before the end timestamp for every machine ID process ID pair. Alright, and then there's a factory website that has several machines each running the same number of processes. Okay. Write a solution to find the average time each machine takes to complete a process. The time to complete a process is the end timestamp minus the start timestamp. And then average time is calculated by the total time divided by the, because that's how average is always calculated. Average will always be the total divided by the number. The resulting table shows the machine ID along with the average time called processing time, and it will be rounded to 3 decimal places. Okay. Not too bad. That's a lie. It sounds like hell. They don't give hints for this question. Interesting. Okay. We have the input table activity. We notice we have 1, 2, 3 different machine IDs, that being 0, 1, and 2, and 2 process IDs, that being 0 and 1. So there's 3 machines, and each machine runs 2 processes at most. If we look at machine ID 0, it has a processing time of 0.894. And then it shows you how it got the value. Okay. Now listen. Because we need to consider 2 different values, as it says here, we need to take the start timestamp minus the end timestamp. We are going to need 2 tables. But you're saying, wait a minute, there's only one table. you can select, let me say select star, that selects everything, right? From table. You can select the same table twice. That's fine. As you saw in earlier queries, I don't know why I'm acting like it's new knowledge. So if I were to select, I'll come back to that. From activity, if I could spell, from listen, activity as A1, I could do another activity table here. It's actually what I was saying, but that doesn't make sense. We'll actually do a join. Join activity as A2. All right, now I have two tables. And if I look at the tables, I want to consider this time, no, it will be machine ID 0 with process ID 0 with activity time end with timestamp 1.520 minus machine ID 0 with process ID 0 with activity type start and timestamp 0.712. Okay, there we go. All right. So join on A1 dot machine ID equal to A2 dot machine ID. This ensures that we are only considering the same machine, right? And process ID is equal to A2 dot process ID. So what essentially happened is, okay, cool, same machine. This ensures now same process on same machine. And A1 dot activity type equals to start. So only consider where A1 is a start and A2 is an end. Okay. Group by A1 dot machine ID. Now you saying group by what? I didn't write anything. All right, it will be, it'll have to be A1 dot machine ID. It'll have to be that, okay. And now average function, okay. It's going to be the A2 dot timestamp because it's only for the end timestamp minus the A1 dot timestamp because that's a start, right? As processing time, and that will be wrong because if I look here, I round to 3 decimal places. Okay, so I need to wrap this in a round function, round, and as second argument, nope, it would be called a parameter because I'm not passing in a named value, so parameter 3. That should work. Process ID is ambiguous. Okay, that makes sense. Wrong. Interesting. A1 machine ID. I'll then round the average of A2 timestamp minus A1 timestamp. I round it off as 3 as processing time. From activity as A1, join activity as A2, only join where the machines are the same, only join where the processes are the same. So process underscore ID, process underscore ID, and A2 activity, that's okay. It should be A1 activity type is start. And there we go, quick fix. So essentially what we did was we had this very large table, and what we said is we only want to consider the table where, no, that doesn't make sense. We have a large table, okay. We want to make a smaller table, a smaller data frame, a smaller filtered out version. So what we do is we only consider machines that have the same ID. That's how we know that they are the same machine. And then we want to go further. We only want to consider where they have the same process ID. Once we have a pair means 2, we take the timestamp minus the start timestamp, and we will have our answer. And we round it because if we didn't, we'd get some weird value because that's how averages tend to work. Unless they're perfect, like, 10 divided by 2, you'd get a 5. 436 milliseconds, not bad. Let's see. I don't even want to read that. No, I don't want to read that. At least now we have some originality in these questions. Cool. All right, let's go to the next question. I am having head pain. Let's see. Steam Free Download is a gorgeous new Elden Ring style RPG. Lies. Move over, Naruto. Jujutsu Kaisen fans are officially competing for the worst final arc in Shonen. What was the final arc in Naruto? Are they referring to Shippuden? They defeat Madara. They defeat the Otsutsuki lady. Then Naruto and whatever her name is gets married. Doesn't it end there? That wasn't a bad arc. Alright, now I need to focus on this question. I'll get rid of this. Alright. Employee bonus. Table is called employee. I have 4 attributes: employee ID, a name, a supervisor, and a salary. 3 integers, 1 variable char. A variable char is a char of some length. Employee, there's 2 tables, oh my god. Employee table of bonus, and that is employee ID and bonus. And then write a solution to report the name and bonus of each employee with a bonus less than 1,000. Okay, I don't even need to know the values. Okay, that's fine. So select, what is it? What do I need? Name and, okay, name and bonus. From, which table is it? It's going to be employee. They both have the same IDs. So it's going to be left join. Yeah, because there's nulls here. Left join. Bonus on. If you notice there's nulls, it's typical. And if it's nulls and you're using joins, it's either going to be left or right. Usually. Just try it as your first method of attack. Alright, that will join all of them wherever they have a match of the ID, but then you want to filter it down even more. So only where bonus dot bonus is less than 1,000. Alright. And let me try running that. I'm wrong. Why are you wrong? Dan, okay. Brad and John. Brad has a bonus table 2 and 4. 2 and 4. Thomas and Dan. 2,000 and 4,000. With a bonus of 500, so we can only consider Dan. Brad and John should also be in the table, but they get null. Unless they're considering that even though null is not an indication of value, especially numeric value, it must still be accounted for. So a bonus dot bonus is null. Because technically it is less than 1,000. Yeah, okay. Alright, cool. Next one. Students and examinations. Oh Lord. Oh Lord. 2 tables. Student ID and student name from the students table. Oh. And subjects table. And examinations table. Subject name, student ID, subject name. Write a solution to find the number of times each student attended each exam. I can return the result table ordered by student ID and student name. The result format is in the following example. Okay, so I need to write a solution to see the number of times each student attended each exam. Okay, so from here I'll get the ID and name. All right, from subjects table I'll get subject's name, and I will only be able to get counts from the examination table. So it's 3 joins. No, 3 tables, so it's 2 joins. 56.9%. Okay, 3 tables, 2 joins, ID, name, subject, count. Okay, let's start off simple. Select students from the students table. So students dot student name, no, student ID, because that's the first one, and then students dot student name, right? And then it's obviously going to be from the subjects table that I know. Subjects, and it's going to be dot subject name. Why am I prefixing it? Because I like to. And then I can only count from the examinations table. So count examinations dot subject name. Because if you're in the exam table and if a subject name appears, it means someone sat down for that exam. As what? As attended exams. Okay. Let's see, students.student ID, students.student name, subjects.subject name, and count examinations.subject name. Okay. From students, now how will I join on the students, on the subjects? How will I join on subjects? Let me think. There are no rows. I mean, there's no attributes in common. I can't do a using. There is one more. What if? All right, take all students table rows, take all subject table rows, have them, wait, for each row, oh yeah, that's it, okay. So for each student, say Alice, consider the student taking 3 subjects. For each student Bob, consider Bob taking 3 subjects. For each student John, consider John taking 3 subjects. For each student Alex, consider Alex taking 3 subjects. And you do that by using something called a cross join. No. Cross join. Yeah, okay, there we go. Cross join will take 2 tables and it will return the Cartesian product. So essentially, say I had, let me say table, table 1. Table 1 consists of an ID and a name, and I had a 1 and 2, and say name was A and name was B, and table 2 was just say subject, and I had math and science, and if I did table 1 times table 2, it should be for the student with the ID of 1 and name A, it will be math, and then repeat it again, but this time for science, and then it'll be student with 2 who's as B, and then 2 as B, again math and science. That's what Cartesian product does. So cross join is a Cartesian product, but then I'll still have to consider something else. They're not done. I need to consider how to join all the tables. Okay. Left join because I need to count for nulls. Examinations on students dot student ID equals to examinations dot student ID. Of course, I mean there's no other column in common with these. No, actually subject name, yeah, but no, we're not doing that. Student ID and subjects dot subject name is equal to examinations dot subject name. Group by students dot student ID students dot student name students dot subject name. That's how I'm counting, okay. Then finally, order by students dot student ID. Now, obviously, if you look in this, you're like, why am I bringing up the solution so fast? Because I spent probably, I think, maybe an hour max trying to figure it out the first time I did it, in all honesty. Right. Subject name in group statement. Students dot subject name. It should be subjects table. Yeah, and there we go, outputted. You will get the name, the ID, the subject name, and the number of exams a student participated or sat in for. Hey yo, there we go. This is basically same as mine without being as neat, I would say. Alright, let's go to the next question. My ears are hurting. Alright, our first medium question. I'm going to get rid of everything. Confirm. Alright. Managers with at least 5 direct reports. We are given the employee table with 4 attributes, 2 integers that be ID and manager ID. And we are given name and department, which are variable chars. Before we go on, let me just think. If I do all of these and then I do these and these, yeah, I'll just make one large video because it's going to take me a very long time. Okay. ID is a primary key for this table. Each row of this table indicates the name of an employee, their department, and the ID of their manager. If manager ID is null, then the employee doesn't have a manager. Oh, so sad. I need to write a solution to find managers who, so 5 direct reports are 5 people who report to that manager, okay. So write a solution to find all managers with at least 5 direct reports. Return the table in any order, okay. In this case, John, and if we consider John has an ID of 101, 1, 2, 3, 4, 5, okay, he barely meets it, but that's it. Let me think. Let's break this up. Let's only consider the manager ID from in the employee table. And I'll then do having a count of manager ID greater than 4. But that won't work because I'll have to do a group by, because if I didn't do a group by, I'll get one value. Group by manager ID. Okay. So what this is going to do is it's only going to poop out the manager ID attribute from the employee table, but only where that manager ID appears more than 4 times for each manager ID. Now if I do that, I get wrong, but I get the manager ID of 101, which happens to be the manager ID of 1. Okay. Then I do a subquery, select name from employee, where ID in, and then I'll cut this, paste it, and that works. Yeah. And there we go. I am feeling a little sick. Anyway, just a few more. We now to reset. Okay. Okay. We have the table called signups with two attributes, user ID, which is an integer, and timestamp, which is a date time. And then you can read the rest yourself. And now we have a table called confirmations with an integer user ID, a date time of timestamp, and an action which is enumerable, which can only be confirmed or timeout. Okay. We are told the confirmation rate of a user is the number of times confirm messages divided by the total number of requested confirmation messages. The confirmation rate of a user that did not request any confirmation messages is 0. Round the confirmation rate to 2 decimal places. Write a solution to find the confirmation rate of each user. And then information down here. Okay. Let me think. Let me think. Let me think. I'll have to get the user ID from one of the tables. And then confirmation rate is because they're saying it's the sum divided by the total, it's obviously average. But because I need to round it, it's going to be round into average. But only count if the value is confirmed. Okay. Select s.user ID from sign ups as S. And I'll have to do a left join confirmations as, let's do C on s.user ID. The only reason I'm passing the alias because I don't want to type a lot. Right. And I'll have to group by something. It's going to be group by user ID. And it's going to be round into average into an if. And then it's going to be c.action is equal to confirmed 1 if so, else 0. We'll count it, but we'll count it as 0. We'll round at 2. Should be there. As confirmation rate. Let's see what's wrong. 3726000. S.user ID, round average if c.action is equal to confirmed. It's because I can't spell confirmed. Yeah. And there we go. We did 3, 5, 8, 11, 14 questions, I believe. Today, alright. So of SQL 50, we did 14 questions. And that's it.